Hi, everyone. I hope you enjoyed playing around with that applet. If you weren't able to come up with an idea about what the derivative of f of g of x is, that's OK. It's not the easiest thing to do, but let's try to figure it out here. So we've got the function f of x, g of x. We want to figure out a formula for dy dx. And let's remember what dy dx is. Dy dx is not a fraction, right? It is the actual derivative. But we get it by computing the limit of a fraction. Now, we normally would write this as f of x plus h minus f of x over h. But if instead I write h, instead of h, at the very start we wrote delta x, and this delta y is saying the change in y. So this is just an alternate way of writing f of x plus h minus f of x all over, our function, the change in y over the change in x for this particular function here. So this would actually be f of g of x plus h minus f of g of x on the top of that. And if things weren't complicated enough, let's introduce a new variable. So let's introduce the variable u, which we're going to let stand in for g of x, so that instead of having to write y equals f of g of x, we can just write y equals f of u. And I know this might sound funny. This is an interesting variable to choose, letter to choose. But this is the standard. All math books use this letter. We'll use it again near the end of the semester when we're doing something called u substitution. All right, so I'm trying to compute the limit as delta x goes to 0 of delta y over delta x. What if I just start with delta y over delta x? Is this a bona fide fraction? We know that dy dx is not a fraction. Is this a fraction? This is a real fraction, right? I really am taking a change in y over a change in x. These are actual numbers. Well, if I multiply by 1 in a clever way, I shouldn't be changing the value, right? So I can write delta y over delta x as delta y over delta u times delta u over delta x. These are three fractions. But what I really want is a limit as delta x goes to 0. So I can take the limit as delta x goes to 0 of this fraction. But to be fair, if I take the limit of one side, I've got to take the limit of the other side as well to maintain the equality. So I have to take the limit as delta x goes to 0 there, and the limit as delta x goes to 0 here. And again, this is some property of limits about if the limit exists that we can do this to a product. I'm not doing anything too illegal there. I'm not doing anything illegal at all there. This thing here is what we want, right? This is saying limit as delta x goes to 0 of this. That's another way of saying dy dx. But remember, dy dx is not an actual fraction. We've now taken the limit. This is the derivative. Let's skip over this middle one for a second. This looks almost exactly the same as our dy dx, except that in place of the y, we have a u. So this should certainly be du dx, the derivative of u. And remember, u is our function g of x. So this is going to become g prime of x. This looks like it should be dy du, except what's the problem? If this is really dy du, this whole thing, what should be going to 0 on the bottom here? Not delta x, but delta u. So the question is, can I cross off delta x going to 0 and write delta u going to 0, as I would like to do? And then, therefore, this would become dy du. Well, let's look at a graph here. We've got our function u equals g of x. If any of these derivatives are even going to exist, meaning if there's any point in even computing them, the graph has to be continuous, right? If we have a discontinuous function, as we saw when we sketched derivatives a couple weeks ago, there's no hope of the derivative existing. So let's imagine we have some continuous function. We have a delta x, which causes a corresponding, normally we have a corresponding delta y, but remember here we're using u as our intermediary variable. So the delta x causes a delta u. And then the delta u causes a delta y, because we have one function inside of another. So this is ultimately going to be called the chain rule. There's a chain of things happening. You change x, that causes a change in u, and then the change in u causes a change in the output y at the end, delta y. We know that delta x is going to 0. So imagine here, as delta x goes to 0, as this gets smaller and smaller and smaller, what is by necessity going to happen to delta u? If now my delta x is just this little piece down here, delta u is also getting smaller, right? And if this is a continuous function, the only possibility is that as delta x goes to 0, delta u must go to 0 too. You can try drawing all sorts of different continuous functions yourself, and you will see that as you squeeze this thing smaller and smaller, the output, delta u, gets smaller and smaller as well. Meaning I am justified in crossing this off and writing delta u goes to 0 instead, which is what we were hoping we could write. Because now, what is this? I have delta y over delta u as delta u goes to 0. That is just the same as writing dy du. Now, it might look like we spent a lot of time and didn't really do much, because all we did was we changed all the deltas here to d's here, right? But that is a lot, because these three things are true fractions. These three things are not. These are derivatives. We've taken the limit, right? So a lot happened in going from here to here. Now, all that's left is to rewrite this. Our product rule and our quotient rule had f's and g's. They didn't have y's and x's and u's in it. So this is saying the derivative of what? This is saying our function y was f of g of x. So this is, we're saying we're taking the derivative of f of g of x. And what are we going to get when we do that? Let's skip this one for a second. This is du dx. U is g of x. So this should be what prime of what? This should just be g prime of x. This is dy du. Y is f of u. So this should be f prime of u. But remember, this u is something that we ourselves introduced. It wasn't part of the original thing. It was really g of x. So this is the same as writing f prime of g of x times g prime of x. Is that the formula that you guessed by playing around with the applet? If so, congratulations, you did very well. If not, we're not sure how that applet was going to work, whether people will be able to guess it or not. This is called the chain rule. So we'll just summarize it in one go here. d dx of f of g of x is f prime of g of x, then times g prime of x. So we'll practice with this in the next video, but the warning is to notice that the g prime is not inside of the f prime. So you start with a function f of g, you take the derivative of the outer function, but the inner function doesn't change. This g of x stays the same. The most common mistake that people make when you're trying to apply the chain rule is they put the g prime in here instead of out here. So let's keep that in mind as a warning. All right, I've mentioned this. You might have seen this off on the side here. G.H. Hardy, we mentioned him before when we were talking about our fun game. Remember, he and the brilliant Indian mathematician Ramanujan proved this thing about partitions. So he wrote a book called A Course in Pure Mathematics, and that was widely used in Great Britain last century. And it gave this very same proof. You notice that I never called this a proof because, unfortunately, there's a little flaw here. What is it that was actually possibly dangerous that we did here? It was when I very innocently seemed to multiply by delta u over delta u, right? So it seemed like we're multiplying by 1, and we are in most cases, except if by bad luck delta u happened to equal what number, are we not allowed to multiply by that number over itself? That number is 0. If by bad luck for us delta u had been 0, so if some other place in the graph we were over here, and maybe our delta x, let me just draw a different picture. If we had had, by bad luck, a graph that went like this, say, and my delta x happened to fall right here, then what is delta u? Delta u is 0. So don't feel bad if you missed that. Everybody who read the first 3 editions of this book missed it as well. It was only fixed in the 4th edition, even though it was widely used. So, and unfortunately, in order to fix that, we have to do a tremendous amount of extra labor, and it's not worth the trouble. This is the idea of why the chain rule works. In order to fix that one little special case, we have to worry about a lot of irritating little details that don't help you really understand why the chain rule works in the first place. So this is why the chain rule works. You have a change in x, it causes a change in u, which causes a change in y. And this is our chain rule. We put it in a box so we can remember it. And now in the next segment, we will practice using it.